Hello and welcome to this video about the map generation. Glad you tuned in. I think this video will be really interesting, and later on we will also look at the code that I wrote for this map generation, but only some parts of it because there's a lot of code. And if you are not familiar with coding, that's absolutely no problem because I will explain a lot of the things visually, and yeah, that way everyone can understand it, and just skip the parts where there's code if you don't like code. So I will start with the basic explanation, for example the different colors, what they represent, which things I have to generate, because there's not only the visual map but also some colliders. Then I will show you the different building blocks that are in the map, or that create the map. And then I will go into the visual map generation, by which I mean we take the image and generate the map. Everything you see will be generated there. Then we go in the building layer collider generation, which basically means everywhere where is, so every pixel where there's stone, we need a collider because we can't build in stone. But if you have one collider for each zone, that's a little bit unperformant, so I implemented a more intelligent way, more performant way, but yeah, you will just have to watch it to understand it. And then I will talk and show you how I generate the camera colliders. This is just really short, because it's not that complicated and not that different from the previous part. And lastly, there will be the outro. So enjoy the video and have fun. So let's start by having a look on the little images that I use for the map generation. So it's just a really pixelated image where single pixels decide different things. So the map is not only the visual map, but also building block areas where you can't build. Of course, this is dependent on the map, so basically you can't build in stone. So everything that's gray here is building block area. But I don't want to attach a box collider on every little tile, because that would be a lot of box colliders. I want to do it in a more intelligent way. For example, you can just unite all of these box colliders into one. You only need this one, and of course down here we need one, here we need one, etc, etc. But this means a lot less box colliders. Then we also got camera movement blocking colliders, which basically means the camera shouldn't be able to move outside of certain regions. This also is generated fairly easy, but they also need a certain set. For example, if we got it like this, this one has to tell that the camera can't move on the left. This one tells the camera can't move on the right. This one means the camera can't move to the bottom, and here of course we need also one for the top. Yeah, that are the three different parts. Now let's come to the different colors. So as I already said, the gray color is just stone, the white color is grass, the blue color is basically tells that here is a player, and the black pixel is used for the main goal pit and the direction in which the player is looking, I'd say. So for example here, what is important to move the player here and to rotate him accordingly, so that for example the little blue tile where the forces are spawning is over here. Let's make this red. And yeah, of course the main goal pit is over here. Yes, that's all for the colors. And next I will show you the different building parts in Unity. So here we are in Unity, and I will just show you the different building block parts. So first of all, we of course have the stone only block. We got the stone island block, which has 4 tree sides. Then we got 3 tree sides block. We got 2 tree sides block. And we got 1 tree side block. We got a 1 tree block, because there's only 1 tree. By the way, this bug is just in this program 3D viewer. I don't know why, but it is there. Oh, sorry. Then we got 2 tree sides. These are all the paths that we have. With these, all the maps are generated. Of course, many of them have to be rotated. So let's directly look into the map generation in terms of the map models. So there, what do we have? So basically, of course, we are going through each pixel, and then if the color is the stone block color, then we want to know which stone block it is. If it's the grass block or something else, we don't care, I'd say. Of course, if it's a black color, then this means we have to instantiate a main goal pit. And if it's a blue color, we also got to move the player there, etc. But in terms of map generation, just a map, we don't care. So basically, if it's stone, then we check which type of stone. And yeah, we have a lot of different stones. We got the stone only, 1 tree side, etc, etc. You see, I wrote a method for every one of them. You could definitely make it a little bit more performant by writing everything into one method, because there are certainly some duplicated checks in here in the different methods, but I try to keep them at a low count, and I don't really care if it is not perfectly optimized, because it's in front of the game and it loads pretty quick, I'd say. I mean, of course, it depends on on how big the map is, but it is not particularly slow, I'd say. So I'm okay with that. And we will look at one example. We also get the number of stone blocks at the beginning and then insert them into every method. Let's say we look at is block 2 tree sides, which means we are looking at this building block. So basically, if you think about it, we need at least 3 grass blocks, because we got trees here. And how many stones do we need? Well, here has to be a stone, here has to be a stone, and here has to be a stone, because there are no trees. So we need a minimum of 3 stones, but we also can have more. The maximum would be 5. So between 3 and 5 stones. You should see that in the method. Yeah, is it 3, 4, or 5? And in that case, we simply just check above. So check on the right and on the left. And if there's one on the right or one on the left, then we check beneath and above. So basically, sorry, Unity, here again the view, we look, hey, do we have something here? If yes, then do we have something here? No? Okay, then do we have something here? Yes? Okay, then it works. Because if here's grass and here's grass, then it's sure that it works. Of course, theoretically we should also check here, but there's no such building part that is grass here, and here shouldn't be a stone. But of course, with the map generation, you could definitely create glitches by not following certain rules. Yeah, that's one example, and yeah, we don't have to look in all of them. Next thing, which is really interesting, I think, therefore I will start a game, is the are the building block tiles As you can see, we have 1, 2, 3, 4, 5, 6, 7, 8 building block tiles for a lot of stones. Let's count them. 539, because the ground is in there too. So there are a lot of stones, and we only got 7 building block colliders, which is really nice. And the way it works, I want to show it in Gravit Designer. Okay, so in Gravit Designer I will visualize for you how it works. So we start with the pixel here. Let's make it red. Now we will check this row. Works, etc. until it's there. If this row is complete from left to the right, then this is marked, and we continue until one row is not from the left to the right completely with stone. So in this case we finished perfectly. Next thing, wait, let's do that let's say, I don't know, purple, and we continue. So this red, we continue. Okay, here it is stopped. Oh yeah, and yeah, I should also tell you that if it is finished, then this part is blacked out from the image. So basically we create another image, clone it, and then we black it out, this part. Then we continue, and the black parts are ignored. So that's why we start here. Now this will work until here, then there's grass, so it doesn't work. Same here, it gets blacked out, so it doesn't count anymore. Next thing where we start is here, because we can't start in a grass block. Then it goes again, and the interesting part happens here, because it starts here and it goes to the right, and you'd say, okay, it's not a complete row, but it doesn't think in that wise, or it doesn't work like this, because it works with the starting point. So if from the starting point to the end point it's complete, then we continue until we are down here. So that's why it's pre-performed. Also here I forgot that even if the row is not complete, the next row is checked, and if it is not less than the first row, then it's something like this. Yeah. That's basically how it works. Of course you can see the code if you want. Basically it's here. So the first for loop is with the X, the second is with the Y. So maybe I showed it wrong. Wait, first X, then Y. Yeah, so I think I showed it wrong. Well, it doesn't really matter, because it works. And that's the most important thing, and it isn't important if you start from X or Y. It also, I really don't know how it is in Unity. It is a little bit confusing, and of course after that you have to put in the right position. You already see this formula, yes. But it's just that big because basically we use the positioning is a little bit more complicated. Just look at the formula, it works. I had to try around with that a little bit. Generally this method is really short, but it was really complicated, and of course you have to scale it accordingly. Everything is stored, but it is definitely not that easy. Okay, lastly we got the camera block tiles. There I also did a not that performant way. Basically we are checking, and we are checking again and again and again, because we can have 4 different camera blocks, if you say so. And yeah, I was too lazy to do it in a more intelligent way, so I just copy pasted and changed the important values. Of course I could have done a method and then just use that method. That would be way more clean, but I didn't want to do that. I was too lazy. Yeah, if the code is really interesting for you, you can just look at it, but it's not that different from the other block, from the other code. It's even simpler. And here's just the positioning and the can't go direction. This is something for the camera, because the camera needs to know where it can't go if it collided with one of those. Yeah, so that's it with the video. I hope you enjoyed watching it and that you learned something maybe. Especially this part with the building blocks is really interesting, I think, and it took some time, I'd say. Also the map tiles obviously also took a time. One small fact there is that of course everything is static because it doesn't move, but if you remove the static attribute and move it, it does move, because Unity is amazing and creates a united mesh basically, which means it's more performant basically, and that's cool. I love Unity for that. And that's it with the video. Don't hesitate to like and subscribe, and see you in the next video. Have a wonderful day. Goodbye.